In this class, we're going to learn how to solve questions on Anova table with unequal replicate. We are given the question on the screen. The table below shows the weight gain of African giant rats on an experiment. Study the table above carefully, carry out the Anova, and interpret your result as appropriate. Note that the F tabulated is 2.99. Okay, now pay attention, please. This is the table that were given in the question. You understand? This is the table for the data. This is the data generated from the experiment. You understand? Okay, now if you look at this table, you can see that it is complete randomized design. Why? Because there is no block. Okay, so and you can see that these treatments, they repeat themselves unequally. Their replicate is not equal to each other. For example, look at treatment 1. We have how many replicates? 1, 2, 3, 4, 5, 6, 7, 8. 8 replicates. Treatment 2, we have 1, 2, 3, 4, 5. 5 replicates. Treatment 3, we have 1, 2, 3, 4, 5, 6. 6 replicates. And treatment 4, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 replicates. You can see that these replicates, they are not equal. So there is a way to go about it. So I want you to pay attention. I've already drew out the Anova table that we're going to use. You understand? So this is the analysis of variance table that we're going to use to calculate the for the Anova table that we have to compute. This is the table that we're going to use. Do you understand? Okay, so don't be confused. I just drew it out so that by the time I'm done with the calculation, I'm just going to input the parameters that I calculated. Okay, now we cannot use this table unless we calculate some parameters. So those are the parameters that I want to calculate now. Okay, now the first parameters that you need is correction factor. But before that, first take the sum of all the individual treatments. You understand? Take the sum of their replicate. For example, treatment 1, take the sum of this. You understand? So I'm going to have another column which will be at the base, extreme base. Another column. Okay, so let's start with treatment 1. Sum all these values together. You understand? So that will be 51.6 plus 45.3 plus 42.1 plus 42.6 plus 47.7 plus 50.8 plus 50.6 plus 46.6. That is 377.3. 377.3. You understand? Okay. What of the treatment 2? If you sum all this together, you're going to have 240.7. And if you sum all this together as well, you're going to have 296.4. 296.4. And all this, you're going to have 474.4. Okay? Now, don't forget that we have been given that F tabulated is what? F tab is what? 2.99. I just put it here. While you are solving your question, you don't need to put it there. For me to remember, that's why I put it here, okay? Now, having done this, we can now proceed to calculate the correction factor. The correction factor is given by this formula. The summation xi squared all over n. You understand? I'm very sure if you are part of our previous class on analysis of variance, you shouldn't find this difficult to calculate because I explained in details. So the meaning of summation xi squared is that you have to sum all the treatment together, sum their replicate, then you have to square the sum and then divide it by the numbers, the total numbers. For example, please pay attention. Summation xi squared means that you have to square 51.6, add all of them together. All the replicate that you have here, add it together. And if you add them together, that is also the same thing as saying that 377.3 plus 240.7 plus 296.4 plus 474.4 all over the total numbers of all of them. Square it. All over the total numbers of all of them. Let us count. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. You understand? So we are having n will be what? 29. You understand? You know what I did? See, in some textbook takes them individually, you understand? That is, they add 51.6, add this. It's still the same thing, you understand? The reason why I did this way is because I've already taken the sum of each treatment, so I can easily use the 4 values that I have here and get the total. If you sum all these totals together, you're still going to arrive at the same answer, okay? So don't get confused. Now, we have 29. So here, I'm going to have the correction factor is equals to now. So, CF means the correction factor, okay? Now, add all these values together. That is 1388.8. 1388.8 squared all over 29. Okay, so the correction factor is equals to 1388.8. That is 1928,765.44 all over 29. Okay, so the correction factor here is equals to divide that value, divide 1,928,765.44 divided by 29. That is 66,509.15. Okay, so the correction factor is equals to 66,509.15. I just wrote it because I'm going to need it. Now, having calculated the correction factor, we can now proceed to calculate the other parameters. And the next parameters that we are going to calculate is the total sum of squared. Okay, so kindly take note of the correction factor, and please, I beseech you, please don't, when you're calculating any parameters, don't make mistake. Okay, don't make mistake. So that is the value for the correction factor. I can erase this now. Let's erase it so that there will be space to calculate the total sum of squared. Now, the total sum of squared is given by this formula. TSS, total sum of squared, is equals to the summation of xi squared. Okay, summation of xi squared minus n. You understand? Please kindly pay attention. I'm going to explain. And even if you are part of our previous class on Anova, I've done series of past exam questions on this concept, Anova. So if you are part of the class, you can easily get this concept. The meaning of total sum of squared is summation xi squared. The reason why I have xi is because there are many replicates. You understand? That is, we have to square individual replicate, and then we're going to sum the square together. That is the meaning of summation xi squared. Then, oh, sorry, this should be correction factor minus correction factor. You understand? Minus correction factor. The correction factor that I've already gotten is what? 66,509.5. So the total sum of squared simply means the sum of the square of individual replicates. Take it one by one, square them, then subtract the correction factor from their sum. That is the meaning of the total sum of squared. Okay, so that means I'm going to square 51.6 squared plus 45.3 squared plus 42.1 squared plus 42.6 squared plus 47.7 squared plus 50.8 squared plus 50.6 squared plus 46.6 squared plus, you move to the next one, 40 squared plus 46 squared, then you go. Just put an infinity dot. You understand? Okay, this is not an infinity dot. Just put dot, which signifies that there are other values. All these values. Then to the last one, which is 50.1 squared. 50.1 squared. Then put a parenthesis. Subtract correction factor. The correction factor is 66,509.15. You understand? Please kindly pay attention to all this calculation. Okay? So that we won't get confused in the exam. What I did is that I just square all the replicates. You understand? Then, if you square them, you're going to sum them together and then subtract your correction factor. You're going to get the total sum of squared. Okay? So, and if you take the square of all the replicates, their sum is what? If you all this sum, the sum of this square is what? 66,993.44. minus 66,509.15. Okay, so the total sum of square is equals to, take the difference, you're going to have 484.29. okay, 484.29. That, so let me put it here as well. The total sum of square TSS is equals to 484.29. okay, now let us proceed to calculate another parameter that we need on the table, which is the treatment. You understand? I'm very sure you've written this. Okay, so let's proceed to calculate the treatment sum of squared. Master all the formulas that I'm giving you. Okay, master all the formula and take note of the steps. Do you understand? Take note of the steps. Now, let's calculate the treatment sum of squared. Please, this is where I want to pay attention. You know, I've solved many questions on complete randomized design, experimental design that involves CRD, and most time all of them have equal replicates. But if you look at this, the replicates are not equal. You understand? So it is this place that I want to pay attention here. Now, to calculate the treatment sum of squared, please pay attention. Let us represent it as T, small letter t, treatment sum of squared. This is the formula that we're going to use. Treatment sum of squared is equals to summation ti squared all over n. I'm going to explain. See, the meaning of this formula, summation ti squared, it simply means you have to square the sum of the treatment. You understand? Listen to the explanation again. Don't forget that we have already taken the sum of all the treatments. You understand? We have already taken the sum of their replicate. For example, the sum of the replicate for treatment 1 is what? 377.3. You understand? So now we have to calculate it individually first before we can use this formula. So let us calculate for T1. T1. The T1 will be, the summation is what? 377.3. So I'm going to have 377.3. Please pay attention. All over n. N is the numbers of replicate that we have, which is 1, 2, 3, 4, 5, 6, 7, 8. You understand? So just square this all over 8, Abby. I think you have 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So we are having 8. So let's punch our calculator. 377.3 squared. 0.3 squared all over 8. So that with T1 will be equals to 142,355.29 all over 8. You understand? So for T1 we have 117,794.41. So that is for T1. Let's calculate T2 as well. T2 will be equals to, the sum of the T2 is what? 240.7. 240.7 all over, let's just square it as well. All over n. N will be what? 1, 2, 3, 4, 5. So I'm going to have all over 5. So T2 will be equals to 240.7 divided by 5. Oh, sorry. Square it first to 240.7 squared. That is, let me change this marker. Okay, 240.7 squared, that will be 936.49, okay, all over 5. So T2 is equals to, divide this, we are going to have 11,587.3, okay, so that is T2. Let's calculate for T3. Don't forget, I'm calculating it individually now. So just pay attention. So for T3, we're going to have the summation of the replicate is what? 296.4. So I'm going to have 296.4 squared all over. Now let's count. We have 1, 2, 3, 4, 5, 6. So we have all over 6. So T3 is equals to 296.4 squared. That is 87,852. 87,852.96 all over 6. All over 6. So the T3 will be equals to 87,852.96 divided by 6. That is 14,642. 14,642.16. You can see it, okay? Now let's proceed for T4. Let's calculate for T4 as well. So for T4, we're going to have, see, for T4 to 24, the summation is what? 474.4. So I'm going to have, for T4, we're going to have 474.4 squared all over. Now let's count the numbers of replicate that we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this will be all over 10. Do you understand? I'm very sure you didn't have any question. And if you have any, if you have any question, let me know in the comment section. Okay. So now, if you square 474.4, that will be a very large number. You understand? So let's put the calculation here. T4 is equals to 225 is not even 225,055.36 all over 10. You understand? So let's come back here. T4 is equals to, it's because of the board, that's why I put the calculation, I put the values here. You understand? If you take the square of this, you're going to have 225,055. Okay, so now T4, if you divide this by 10, you're going to have 22,000. Let me just put it 22,505. 505 point 0.54. Okay. Now you can see that we've already taken the total. We calculate it individually. Why do we calculate it individually? It is because they have different replicates. If you have watched our the previous classes on CRD, you will discover that we didn't calculate it separately. We only let's say they have equal replicate. For example, let's say all the treatments are repeated at the same time. For example, 10. So all you have to do is that just take the square of them, sum it together, divide by 10. But now they have different replicates. So in an attempt to help us to understand, we have to take them differently. So I first take the first treatment, I deal with it, take the second, deal with it, take the third, deal with it, and take the fourth, deal with it. Then you can now proceed as follows. TSS, which is the treatment sum of squared, TSS is equals to, you have to sum them together now. I'm going to have 17,794.1 plus T2. T2 is what? 11,587.3 plus T3. T3 is what? 40,642.16, and then plus T4. What's T4? 505.54 minus the correction factor. Please pay attention. Oh, let me put it. You have to subtract the correction factor minus the correction factor. You understand? The correction factor is what? 66,509.15. I hope this place contains it. 66,000 minus 509.15. Okay? I'm very sure you understood how I got the values. 509.15. That is the correction factor actually. Okay, now please pay attention. I'm going to erase this. I'm going to erase this now. I'm going to erase it because we need space to calculate the treatment sum of square. But my major goals is to help you understand how to deal with. I'm very sure if you are part of our previous class, you should be able to do something like this because it is actually related to it, what we've learned in our previous class. But the major goals of bringing this is because of this. It's because of this these steps, you understand? So that's, I'm very sure you understood now. Okay, so if you come across this in exam, you should be able to solve it. You understand? Okay, so I'm going to erase this. Let's erase this. Yes. Okay, so let's proceed. Here I'm going to have the treatment sum of squared is equals to, now if you sum all these values together, let us sum it. That will give us 66,529. 66,529.41 minus the correction factor, which is 66,509.15. Okay, so the treatment sum of squared is equals to, take the difference between this and this. We are going to have 20.26. That is 20.26. 20.26. Okay, let me change the marker. 20.26. So pay attention, okay? 20.26. Now, this is the treatment sum of square. Let us put it here. I represent it as small letter t. You understand? Treatment sum of square 20.26. Now, I want you to pay attention. Having calculated the correction factor, the total sum of square, and the treatment sum of square, we still need we need another value. Another parameter known as the error sum of square. So, I'm going to erase this. The error sum of squared. Error sum of squared. The error sum of squared. In some cases, they call it sum of square error, but I will call it error sum of squared. Error sum of squared is given by this formula: the total sum of squared minus the treatment sum of squared. Okay, the total sum of squared is what? 484.29, and the treatment sum of squared is what? 20.26. 20.26. So I'm going to have 484.29 minus 20.26. That is 464.03. I'm very sure you understood. Okay, the difference between the total sum of squared and the treatment sum of squared will give us the error sum of squared in a complete randomized design. So the error sum of squared, ESS, is equals to 464.03. Now, having calculated all these parameters, let's proceed to compose our Anova table, okay, before we proceed to the interpretation of our answer. Now, the CF, the source of variation can be total, please pay attention. And in some cases, you might not find total on the table, you might not write total, but notwithstanding, I just felt like putting it, okay? If you put it in the exam, you will not be penalized for it. And if you don't put it, I don't know, depending on the lecturer, but I just put this, and we have the treatment, you understand? And we have the error, which is the third one. Do you understand? Now, please pay attention. Here, there are some formula that you need to know, and there's a formula that let me write this treatment very well. There are some formula that I'm going to give you. Treatment, okay? Let's call this one treatment. There's a formula that I'm going to give you that will help you to calculate all the parameters that you need on this table. See, we've been given that the F tabulated is what? 2.99. So let us put that. F tabulated is 2.99. The reason why I put the F tabulated as the treatment is because to interpret our result, we only need to deal with the treatment. You understand? To interpret our result, we only need the treatment. So we are going to we are looking for the F calculated for treatment. That's the goals. You understand? We are looking for the calculated value, the calculated critical value for the treatment. That's the goals of this table, okay? So let's start with the degree of freedom. DF simply means degree of freedom. SS means sum of squared. MS means mean squared, okay? Degree of freedom is given by this formula, n minus 1. You understand? Okay, so let's calculate the total degree of freedom, which is the value of these cells. The total degree of freedom is equals to n. Now, what is the value of n? N is the total numbers of replicates that we have. You understand? So the replicates are 1, 2, this is 8. This is 8. 8 plus, let's count 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 5. 8 plus 5 is 13. You understand? 8 plus 5 is 13. 13 plus 1, 2, 3, 4, 5, 6. 13 plus 6, that is 19. 19 plus 10, that is 29. You understand? So the replicate that the sum of all the replicates. You understand? Now we are not summing them, we only count them. The total numbers of replicates, the total numbers of elements, the total numbers of data, the data set on this table is called n. You understand? So the degree of freedom for total will be 29 minus 1, that is 28. You understand? 29 minus 1, that is what? 28. So we're going to have 28. Here I'm going to have 28. Now, treatment degree of freedom. The degree of freedom for treatment is equals to the total numbers of treatment that we have minus 1. How many treatments do we have on this table? We are having 4 treatments, which is T1, T2, T3, and T4. So we are having 4 treatments. That means I'm going to have 4 minus 1. 4 minus 1 will be what? 3. So I'm going to have 3. So here will be 3. Now the error degree of freedom. The degree of freedom for error will be the total degree of freedom minus the treatment degree of freedom. Total degree of freedom is 28. And the treatment degree of freedom is 3. So I'm going to have 28 minus 3 is what? 25. Okay? So that will be 25. Here will be 25. Do you understand? Okay? Now, having gotten the error degree of freedom, you can proceed to calculate the sum of squared. Oh, we've already calculated, sorry. So all you have to do is just put the values inside the Anova table, okay? I mean, on the Anova table rather. So here we're going to have 484.29. For the treatment, we're going to have 20.26. And for the error, we're going to have 464.03, okay? Now, let's calculate the mean squared. Mean squared is given by this formula. Mean squared is equals to the sum of squared all over the degree of freedom. Sum of squared all over the degree of freedom. Now, to calculate the total mean squared, in some cases you don't need it, but notwithstanding, I just want to fill this table. So, total sum of squared all over the total degree of freedom will give us the total mean squared. So, total mean squared is equals to, total sum of squared is 484.29, and the total degree of freedom is 28. 484.29 divided by 28. Let's calculate. So 484.29 divided by 28, that is 17.2, okay, 17.30. You see, we don't need it, you understand? I just calculate it, you know. I just calculate it, we don't need it. What we need is the treatment mean squared and the error mean squared, you understand? So in some cases, you might find this place as dash. But since I've already calculated, let me just put it here. 17.30, okay? So we don't need it actually. So you might decide to put it, and you might decide not to put it. I just calculate it. Now let us calculate the treatment mean squared, which we need. Treatment mean squared will be equals to treatment sum of squared all over the treatment degree of freedom. You understand? Now, the treatment sum of squared is what? 20.26, and the treatment degree of freedom is 3. So 20.26. Please pay attention. 20.26 divided by 3, that is 6.75. So I'm going to have 6.75, okay? 6.75. Do you understand? Now, let us calculate the error, the mean square error, or error mean squared. You understand? The error mean squared, EMS, is equals to the error sum of squared. You see, if you are dealing with this in exam, show your solution, okay? Show all this solution. Put the respective formula. You understand what I'm trying to say? Put it inside your solution. If the lecturer needs this, he's going to mark it. If he doesn't need it, he's going to overlook it. It is necessary to put it. But in a situation whereby he didn't put it, the lecturer might need it and be querying you that how do you get this answer? So in an attempt to, maybe you did, it might be thinking that you cheated in the exam. So it's necessary that you put it, okay? Put the calculation there. Error sum of squared is equals to, error mean squared is equal to error sum of squared all over error degree of freedom. Error sum of squared is 464.03 and the degree of freedom is 25, okay? So 464.03 divided by 25, that is 18.56. 18.56. So here is 18.56. Don't forget, the goals is to determine the F calculated for treatment. So we want to interpret our answer. We cannot interpret the result without determining the calculated critical value for the F for the treatment. You understand? Because the analysis of variance is carried on the treatment. Okay. Now I'm very sure you've written this. Okay. So now F calculated is given by this formula. F calculated is equals to mean squared, that is treatment mean squared all over the error mean squared. You see, this F calculated that you see here, they can also call it variance component. You understand? So people call it variance component. Are you getting it? So treatment mean squared. Treatment mean squared is what? 6.75. So I'm going to have 6.75 all over error mean squared, which is 18.56. 18.56. Okay. Put dash here. Put dash here as well. So 6.75 divided by 18.56. That is 0.36. 0.36. 0.36. Okay. So that is the critical the calculated critical value for the for this data, 0.36. Now you can see that the F tabulated is equals to what? 2.99 as given in the question, and the F calculated is equals to what? 0.36. That is what we calculate. Now you can see that F calculated, see, listen, I want to interpret the result now. Okay, you can see that F tabulated is greater than F calculated. F tab is greater than F car. So since the F tabulated is greater than the F calculated, we conclude that the experiment doesn't show a significant difference among the treatment that is involved. You understand? You know, we have treatment 1, 2, 3, and 4, okay, which are the weight gain by the African giant. Okay, so that's the interpretation. So we've come to the end of the class. Now don't forget to hit the like button, and if you want to be part of the channel, kindly subscribe. Okay.